So the probability of 0 queens means that for the first card that we pull, the number of cards that are available in a 52 card deck that are not queens is 4 less than 52. So 48 out of the 52 cards are not queens. So it's a very large probability that you're going to be pulling out something that's not a queen. Then if you've already pulled out something that's not a queen, you've already lost 1 out of your 52 card deck. You've also already lost 1 out of the total 48 that are not queens. So that's now you're only left with 47 out of those that are not queens. And then again, we have pulled out a not queen. So now we have only 46 cards left that are not queens. And we only have a total of 50 left because we've already pulled out 2 cards. Dependent events, this idea, you can see this idea of factorial here happening. Multiplying them all together, which I already did, is 103,776 all over 132,600. This fraction simplifies down to 4,324 over 5,520. All right, so that's 0 queens. Now what about 1 queen? And this is where I had to stop for a second and make an experiment in my head. I said, well, will the probability matter? Will the probability change if we're talking about the queen being the first card that's pulled, the second card that's pulled, or the third card that's pulled? So I said, well, let's figure out the probability of all 3. So I went in and I separated my space into 3 separate categories. What happens if the first card that I pulled was a queen? What's the probability of the first card I pulled was a queen and then the subsequent 2 are not? And it works as 4. The first one is that you have 4 cards that are queens out of a total of 52. And then next you want to pull no queens. Well, since the idea is that we pulled a queen in the first event, the number of not queens stays the same. We still have 48 cards in our deck that are not queens. But now we only have 51 cards because we pulled out 1 card that was a queen. And then if the second one was not a queen, we would have 47 non-queens left out of 50. I didn't want to calculate it yet. I said, okay, well, let's see what's going on because I've noticed that it's all multiplication. And if I multiply these in any order, it shouldn't matter. And that was my hypothesis, and I went and I changed it, and I said, okay, well, what if the first one is not a queen? Well, that would be 48 out of 52. But what if the second one was a queen? Well, that would be 4 out of 51. And then the last one was not a queen. That would be 47 out of 50. And then I went to the last probability, and I said, okay, the first one was not a queen. The second one was not a queen, but the last one was a queen. And because of what we know about the associative property, it doesn't matter what order you multiply these numbers in. And so the fact that even though the denominator is still going down, 52, 51, 50, the fact that the numerators numbers are changing around doesn't change the number that is resulting from this multiplication. So it does not matter where you place the queen if you're talking about only 1 out of the 3 are pulled. It just is that you have to account for that at one point in your multiplication. And the answer was 47 times 48 times 4 is 9,024 over 132,600. Simplifies down to 376 out of 5,525. Last one. Taking what I learned from my previous experiment, 2 queens, it doesn't matter in which order you pulled the queens, the probability will still be the same. So I just said, okay, well, there's 4 out of 52. And then there will be 1 less queen and 1 less card in the deck. but then there will be still the 48 non-queens in there, but still out of a total of 50 cards. Total is 576 out of 132,600, which is 24 out of 5,525. And there you have it. This whole page right here is probability of dependent events versus up here was probability of independent events. So that's the only difference with the multiplication rule, is that you might have this factorial looking pattern with your number when you're talking about dependent events. And that's it. This is it for our probability notes. You have all the information you need to get started on your homework. You also have a quiz today. I will post a video that's optional to watch, but it's called The Birthday Problem, and it's actually really interesting, and it talks about probability and how probability isn't always intuitive. It doesn't always follow what you think it might be, because sometimes the math doesn't seem as straightforward as our brains want it to be. So it's just an optional video to watch, but I do think it's really interesting to see the connection between what our brains want to tell us and what the mathematics is.